TFF wire is rated for a temperature of 600 degrees Celsius, which is equivalent to 1112 degrees Fahrenheit. This high temperature rating makes it suitable for specific applications where higher heat resistance is required. The relevant code references for TFF wire include IEC 60227, which pertains to polyvinyl chloride insulated electric cables, and UL 817, which is the standard for electrical flexible power cables and cords. IEC 60227 specifies the requirements for PVC insulated cables used in a wide range of electrical installations. These cables are designed for low voltage applications and are commonly used for power distribution and general wiring purposes. The standard covers various aspects of cable construction, including insulation thickness, conductor materials, and testing procedures. Understanding IEC 60227 is crucial for ensuring the safety and reliability of electrical systems that utilize PVC insulated cables. UL 817 outlines the requirements for flexible power cables and cords used in electrical appliances and equipment. This standard focuses on the safety and performance of these cables, covering aspects such as conductor size, insulation properties, and strain relief. Compliance with UL 817 is essential for manufacturers of electrical products to ensure that their products meet the necessary safety standards for use in North America. When working with TFF wire, it is important to consult both IEC 60227 and UL 817 to ensure that the wire meets the specific requirements of the intended application. These standards provide detailed guidelines on the proper installation, handling, and use of TFF wire, helping to prevent electrical hazards and ensure the long-term reliability of electrical systems. Additionally, always refer to local electrical codes and regulations, as they may have specific requirements for the use of TFF wire in certain applications. Following these guidelines will help ensure that electrical installations are safe, compliant, and reliable. The temperature rating of a wire is the maximum temperature at which the wire's insulation can operate continuously without degrading. Exceeding this temperature can lead to insulation failure, short circuits, and other electrical hazards. Different types of wire insulation have different temperature ratings, so it's important to choose the right wire for the application. Factors that affect a wire's temperature rating include the type of insulation material, the size of the conductor, and the ambient temperature. Common insulation materials include PVC, polyethylene, and cross-linked polyethylene. Each of these materials has different thermal properties and therefore different temperature ratings. The size of the conductor also affects the temperature rating. Larger conductors can dissipate heat more effectively, allowing for higher temperature ratings. The ambient temperature is the temperature of the surrounding environment. Wires installed in hot environments will have lower temperature ratings than wires installed in cool environments. When selecting wire for an application, it's important to consider all of these factors to ensure that the wire is suitable for the operating conditions. Using wire with an inadequate temperature rating can lead to premature failure and potentially dangerous situations. Electrical codes and standards provide guidance on the proper selection and installation of wire. These codes specify the minimum temperature ratings for different applications and provide guidelines on how to direct wire in high-temperature environments. Dirting is the process of reducing the ampacity of a wire to account for the effects of high temperature. The ampacity of a wire is the maximum amount of current that it can safely carry. Dirting is necessary to prevent the wire from overheating and potentially causing a fire. The National Electrical Code, or NEC, provides detailed information on wire ampacity and dirting factors. Table 310.15. B16 of the NEC lists the ampacities of different types of wire based on their size and temperature rating. Table 310.15. B2 of the NEC provide adjustment factors for ambient temperature. These factors are used to direct the ampacity of a wire when the ambient temperature exceeds the values listed in the table. In addition to temperature rating, other important factors to consider when selecting wire include the voltage rating, the insulation type, and the environmental conditions. The voltage rating is the maximum voltage that the wire can safely carry. The insulation type determines the wire's resistance to moisture, chemicals, and abrasion. The environmental conditions include factors such as temperature, humidity, and exposure to sunlight. Choosing the right wire for an application requires careful consideration of all of these factors. Consulting with a qualified electrician or electrical engineer can help ensure that the proper wire is selected and installed safely. Always follow electrical codes and standards to prevent electrical hazards and ensure the long-term reliability of electrical systems. Furthermore, understanding the specific application of TFF wire is important to ensure it is being used correctly. TFF wire is often used for internal wiring of appliances and electronic equipment. Its flexibility and relatively small size make it suitable for tight spaces. However, it's crucial to verify that the temperature and voltage ratings are appropriate for the intended use. For instance, if the appliance generates a significant amount of heat, a high temperature rated wire might be necessary. The ampacity of TFF wire also needs to be considered. The ampacity is the maximum amount of electrical current a conductor can carry continuously without exceeding its temperature rating. The NEC provides tables that list the ampacities of various wire types based on their size and insulation. It's important to select a TFF wire size that can safely handle the expected current load of the appliance or equipment it is being used in. When installing TFF wire, proper wiring techniques should be followed. This includes using appropriate connectors and terminals, ensuring secure connections, and protecting the wire from physical damage. Loose or corroded connections can cause overheating and potentially lead to electrical fires. Additionally, TFF wire should be properly supported and secured to prevent it from rubbing against sharp edges or other components that could damage the insulation. Regular inspection of TFF wire installations is also recommended. Look for signs of damage, such as cracked or frayed insulation, loose connections, or discoloration. If any damage is found, the wire should be replaced immediately to prevent electrical hazards. In summary, TFF wire is a versatile wiring solution for various applications. Understanding its temperature rating, code references, and proper installation techniques is essential for ensuring safe and reliable electrical systems. Always consult with qualified electricians and refer to relevant electrical codes and standards for guidance. Doing so will help prevent electrical hazards and ensure the longevity of your electrical installations. Understanding the properties of polyvinyl chloride, or PVC, the insulation material mentioned in IEC 60227, is helpful in understanding the temperature limitations of TFF wire. PVC is a widely used plastic material known for its durability, flexibility, and resistance to chemicals and moisture. However, PVC has a relatively low temperature resistance compared to other insulation materials such as cross-linked polyethylene or XLPE or silicone rubber. PVC typically begins to soften and degrade at temperatures above 70 degrees Celsius or 158 degrees Fahrenheit. This is why TFF wire with PVC insulation has a maximum temperature rating of 600 degrees Celsius. While the TFF wire itself can withstand higher temperatures, the PVC insulation will begin to break down if exposed to prolonged high temperatures. The degradation of PVC insulation can lead to several problems, including reduced insulation resistance, increased leakage current, and ultimately, insulation failure. When the insulation fails, the wire can short circuit, creating a fire hazard. Therefore, it is crucial to ensure that TFF wire with PVC insulation is not used in applications where the ambient temperature exceeds its rated limit. In high-temperature environments, it may be necessary to use wire with a higher temperature rated insulation material, such as XLPE or silicone rubber. XLPE insulation can withstand temperatures up to 90 degrees Celsius or 194 degrees Fahrenheit, while silicone rubber insulation can withstand temperatures up to 150 degrees Celsius or 302 degrees Fahrenheit or even higher, depending on the specific formulation. When selecting wire for a specific application, it is important to consider not only the temperature rating of the insulation but also the voltage rating, ampacity, and other relevant factors. The voltage rating is the maximum voltage that the wire can safely carry without insulation breakdown. The ampacity is the maximum current that the wire can safely carry without overheating. These ratings are typically marked on the wire's insulation. It is also important to consider the environmental conditions in which the wire will be used. For example, if the wire will be exposed to moisture, chemicals, or sunlight, it is important to select a wire with an insulation material that is resistant to these elements. The electrical codes and standards provide detailed guidance on the proper selection and installation of wire for various applications. These codes specify the minimum requirements for wire size, insulation type, and installation methods. Following these codes is essential for ensuring the safety and reliability of electrical systems. In addition to the temperature rating and code references, it is important to be aware of the common applications of TFF wire. TFF wire is frequently used in the internal wiring of appliances, control panels, and electronic equipment. Its flexibility and small diameter make it suitable for use in tight spaces, while larger wires would be difficult to install. TFF wire is also commonly used for connecting components on printed circuit boards or PCBs. Its durability and ease of handling make it a popular choice for this application. However, it is important to note that TFF wire is not typically used for branch circuit wiring in buildings. Branch circuit wiring typically requires larger conductors and more robust insulation to meet the requirements of the NEC. When working with TFF wire, it is important to use proper wiring techniques. This includes stripping the insulation carefully to avoid damaging the conductor, making secure connections, and protecting the wire from physical damage. Using the correct tools for stripping and crimping wires is also essential for ensuring reliable connections. Regular inspection of TFF wire installations is recommended to identify any signs of damage or deterioration. Look for cracked or frayed insulation, loose connections, or corrosion. If any problems are found, the wire should be replaced immediately to prevent electrical hazards. In summary, TFF wire is a versatile wiring solution that is widely used in various applications. Understanding its properties, code references, and proper installation techniques is essential for ensuring safe and reliable electrical systems. Always consult with qualified electricians and refer to relevant electrical codes and standards for guidance.